Population ecology is the study of how populations will interact with each other based on the relationship between organisms. So we have a couple of characteristics of population. There is the way that things are distributed. So it's spatial distribution. And that's a particular place where only that population will exist. And then we have population density. That's how much per unit area, how many individuals, how dense that population is in that specific area. And then the other factor is going to be growth rate, how fast or how slow the population grows. All right, so some characteristics of growth. We have birth rate, how many offspring are produced, mortality, which is death, and migration, the movement in or out. And we learned already that immigration is moving out, like E for exit, and immigration is moving into a population. There's a couple of types of growth. We have exponential growth model, and that occurs when there's nothing that's limiting the growth or nothing that's limiting the amount of offspring that an individual can have. So there's no limiting factors. For example, if a plant is growing in a pot that's very small, the pot would be the limiting factor because the plant would have all the sunlight it needed, but it wouldn't have enough space for the roots to grow. So the pot will be its limiting factor. So exponential growth happens in nature mostly when a new population is formed. You're going to have a big jump in the population. Growth can continue forever and ever and ever, and the numbers can be infinite. And this is often represented, well, it's always represented by a J-shaped curve. And this is the graph that shows population size, how it starts out small and over time becomes exponentially large. And this does not have an end. Conversely, the logistics growth model starts normal and then is put into check by something. Most of the time it's by resources. So it starts out like an exponential growth model, but it can reach a carrying capacity. And the carrying capacity is how much that actual land can support, which with exponential, there is no maximum, but with a carrying capacity, you'll start to see a die back of the population after the population has exceeded the amount of resources that could support it. And this is represented by an S curve. So an S curve starts slow, speeds up, and then balances it off. The K is the carrying capacity. You see it's shaped like an S. Okay, so some limits to population growth. There's density dependent and density independent factors. So a density dependent factor is going to be anything that's involving biotic to biotic. So biotic things are all living. So predation, disease, parasites, competition. So examples of predation would be like a lion chasing a gazelle. That's going to affect the population of the gazelle and the population of the lion. Disease is also considered a biotic factor because most diseases are caused by bacteria, which are living things. Parasites, we know that. We'll go over some other gross pictures of parasites. And then we've got competition, which can be war. Competition can be within one species. It does not have to be one species against a different type of species. It can be inside of one species, interspecific. And then density independent factors have nothing to do with other living things. They're directly related to abiotic factors like weather. And then also anything that humans may do that could cause a change in the environment could also be a density independent factor.